Welcome back. Today in this video, I would like to explain you how numbers are represented in the 7-segment display. As you remember, in the previous video, we talked about it's in 51 simulator and I showed you 7-segment display. All right. So what is 7-segment display? It's a component that show us numbers, characters, or any other symbols. It consists of seven individual LED segments, and they are labeled as A, B, C, D, E, F, G, and actually there is a more LED called DP, which means decimal point. There are two ways to control these displays, using common cathode and common anode. But let's assume that we use common anode. So all LEDs share a common positive terminal. So that means that if we want to turn on the first segment A, we have to write 0. If you want to turn off the first segment A, you have to write 1. So basically, 0 means on, 1 means off. All right. So as you can see in the first table, we see the order of our segments A, B, C, D, E, F, G, D, B, and their repeat order. uh, we display our numbers actually with a 8-bit pattern. All right. First of all, we have to write our numbers representation in the binary representation and then convert to the hexadecimal version. All right. So let's work with the first number, 0. So in order to display 0, we have to turn on the A, B, C, D, E, F segments. So, as I told you, on means 0. So A is 0. All right. B is 0 then. C is 0, D is 0, Z is 0, F is 0, but G is not displayed. It's off, so it has to be 1. DP is also off, so which means 1. And right now we have to convert to the hexadecimal version. How do we do it? We just take the first 4 bits and the last 4 bits. The first 4 bits 1 1 0 0, which means C. All right, and last 4 bits are zeros, so it's obvious 0 hexadecimal. But actually we don't write such in such form. Actually, it's correct, but you have to write 0. I will explain you later why. Okay, let's solve for the number 1. So we display only these segments, B and C. So A is 1, B is 0 because it's on, C is on, so it's 0. Other ones are 1. So it has to be 1 1 1 1 F, and 1 0 0 1 means 9. And you have to write 0 here. But, for example, let's solve for the number 4. So which segments are displayed? B, C, D, E, F, G. All right. So it's A, so A has to be then 1, right? B is 0, C is 0, D is 1, E is 1, F is 0, G is 0, and then DP is 1. So 1001, 1001, it's 99 hexadecimal. We don't write 0 here. But why do we write, for example, 0 and 0 in these cases? And also we have to write 0 actually for the 2, 3, and maybe for other ones. You know what's the difference? The difference is a syntax rule in the coding part. When we want to write 0, we have to write 0 C 0 hexadecimal. Why it's not C 0 hexadecimal just? Because our program thinks that if we remove 0 from this line, it means that our program thinks that it's actually not a number in the 7-segment display. It's a name of the variable or the name of the label. So, that's the syntax rule because our program thinks that C is a not hexadecimal digit, it's a just like character, but it's actually a hexadecimal number. So, in order to show it, we have to write 0 here. They think it's just about the syntax rule, but in this case, our program thinks that, oh, it's a number, so it's actually a hexadecimal number. But if you write 0, then it's going to be kind of incorrect. Our program will not understand what kind of number do we display. So if you write 99, it will show up number 4. But if you remove 0 here, it will think like it's just the name of the variable or label or something like that. So that's how we display our numbers. First of all, we have to determine which segments are displayed, which segments are on, and then we have to, if we use common annotate, we have to understand that if it's on, then 0, if it's off, then 1. In a common cathode, it's vice versa. 0 means off, 1 means on. But using common annotate, it's much more understandable because when we want to convert to the hexadecimal, it's going to be much more easier. And what else? We convert to the hexadecimal, and that's it. Yeah, that's how we display it. That's it. Thank you for attention.